Ever feel like just taking out, no itinerary, no destination, just pure freedom? Well,
Mm.
in the vast cosmic wilderness, rogue planets are doing exactly that, hurtling through space all on their own, not bound to any star. We used to think these lone wolves of the galaxy were rare,
Right.
but with the James Webb Telescope, we're spotting tons of them, especially in these bustling young star clusters.
That's right. And it's really shifting our understanding of just how many of these rogue planets or planetary mass objects, PMOs,
UMO.
as they're also known, might be out.
Okay, PMO's got it. But here's the million-dollar question.
Yeah,
How do these rogue planets form in the first place? We're diving into some new research that offers a pretty wild theory.
exactly. The older theories suggested they were either failed stars, not quite massive enough to ignite,
Hmm.
or planets that got ejected from their solar systems due to gravitational interactions.
So either cosmic underachievers or victims of a bad breakup, huh?
You could say that, but this new research proposes a totally different mechanism.
And what's this new idea?
Well, a team of astronomers ran some impressive simulations focusing on the disks of gas and dust that surround young stars.
Oh, okay.
They found that when these stars get close together, their disks can collide.
Well, like colliding disks, that sounds pretty dramatic.
These collisions create what are called tidal bridges, essentially streams of gas and dust connecting the two disks. And here's where it gets interesting. Those bridges can become unstable
Okay.
and collapse, forming these dense filaments. If a filament is massive enough,
Huh.
you can actually clump together and form a rogue planet.
So instead of a gentle birth in a stable solar system, these rogues are born out of a cosmic demolition derby.
That's one way to put it. And what makes this theory really compelling is that it explains why we see so many rogue planets in young star clusters.
Right.
It's like a cosmic mosh pit where these disk collisions are much more likely.
That makes a lot of sense. So we're seeing evidence that backs up this new theory. That's pretty exciting.
It really is. And the simulations suggest that a significant number of rogue planets could be formed this way,
Okay.
possibly up to 14% of them.
Wow, that's a lot higher than I would have guessed.
Absolutely. And that has some pretty big implications for our understanding of planetary systems as a whole. We'll delve into that more in a moment. You see, this new theory suggests that rogue planets are far more common than we originally thought. And that's a pretty significant shift in our understanding of how planetary systems evolve.
Okay, I see what you mean. We're not just talking about a handful of oddballs out there. We're
Right.
talking about a whole population of rogue planets, possibly billions of them.
Precisely.
Mm.
And if they're that common, we have to start thinking about them as a potential part of the evolutionary story of planetary systems.
So how does this change our view of how planetary systems form? It seems like it would make things a lot messier.
You're right. It does challenge the neat picture we used to have of stars and their planets forming in isolation, with so many rogue planets potentially roaming around.
Yeah.
It's likely that some of them could get captured by other stars, becoming part of existing planetary systems.
So we could have rogue planets joining already established solar systems that would shake things up a bit.
Indeed. And that could lead to all sorts of interesting scenarios. Imagine a rogue planet with its own system of moons getting captured by a star that could introduce new gravitational dynamics, potentially disrupting the orbits of existing planets.
Hold on, are we talking about rogue planets causing chaos in otherwise stable planetary systems like a cosmic wrecking ball?
It's not necessarily about chaos. It's more about recognizing that planetary systems are dynamic and can be influenced by external factors. These rogue planets could play a role in shaping the architecture of planetary systems, perhaps even contributing to the formation of habitable planets.
Okay, so it's not just about destruction. It's about the potential for these rogue planets to influence the evolution of other planetary systems in unexpected ways.
Exactly. And this also makes us rethink the environments where we might find life. Remember, the article also mentioned that many rogue planets retain their own disks of gas and dust.
Right, those disks could potentially form moons around the rogue planets, but without a star providing warmth, could those moons ever be habitable?
That's a great question. It's true that they wouldn't have sunlight, but there are other potential sources of energy that could support life. For example, tidal forces between a rogue planet and its moon could generate internal heat, similar to what we see on Jupiter's moon Europa.
So we could have internal oceans on these rogue planet moons warmed by tidal forces rather than sunlight. That's pretty amazing to think about.
It is, and remember, on Earth we have thriving ecosystems around hydrothermal vents, deep in the ocean. Completely independent of sunlight, life finds a way even the most unexpected places.
So are you saying that these rogue planet moons could have similar environments, potentially harboring some form of life?
It's definitely a possibility worth considering. It expands our understanding of where life might exist beyond the traditional habitable zones around stars.
Okay, now that's what I call expanding our horizons. So it's not just about rogue planets themselves, it's about the potential for entire systems of rogue planets and moons, maybe even with their own unique forms of life. It's like we've gone from seeing rogue planets as these cosmic castaways to realizing they might be key players in the grand story of the universe.
Exactly. And the more we learn about them, the more questions we have. Like, for example, how often do these rogue planets actually get captured by other star systems? Could there be a rogue planet lurking undetected in the outskirts of our own solar system?
Now, that would be a discovery, but it makes sense, right? If there are billions of these rogue planets out there, some of them are bound to have crossed paths with other planetary systems over billions of years.
Absolutely. And that raises another intriguing question. What happens to the original planetary system when a rogue planet enters the scene? How would the gravitational dynamics change? Could it cause planets to be ejected from the system, creating more rogue planets in a sort of cosmic chain reaction?
Wow, so rogue planets could be both a product and a cause of planetary upheaval. That's kind of mind-bending.
It is, and it highlights the incredible complexity of planetary systems and how much we still have to uncover. We're only just starting to scratch the surface of understanding these intricate cosmic dances.
It seems like we're moving away from this static view of the universe to a much more dynamic and interconnected one.
Precisely. And this new research on rogue planet formation is a prime example of that shift in thinking. It's forcing us to reevaluate our assumptions about how planetary systems form and evolve, and it's opening up a whole new realm of possibilities for where we might find life beyond Earth.
So where do we go from here? What are the next steps in unraveling the mysteries of these rogue planets?
Well, we need more observations. The James Webb Telescope and future observatories will be crucial in identifying and characterizing more of these rogue planets. We need to learn more about their size composition and whether they have their own moons or even rings.
It's like a whole new era of exploration is opening up focused on these elusive cosmic wanderers.
Exactly. And as we gather more data, we'll be able to refine our models of rogue planet formation and better understand their role in the grand scheme of the universe.
So to our listeners, the next time you gaze up at the night sky, remember that out there among the twinkling stars, there are billions of unseen worlds hurtling through the darkness. Rogue planets, each one a unique and mysterious entity, perhaps harboring secrets that could revolutionize our understanding of the cosmos. And who knows, maybe one day we'll find evidence that we're not alone, not on a planet orbiting a star, but on a rogue world, a lone traveler in the vast cosmic ocean.